Okay, so we'll go through the check for understanding here, and we're going to look at first at the Archaeopteryx, which is a could have been a flying dinosaur or an early bird. And so that's the first problem we're looking at, and we'll be looking at some more birds here called the merlins on the next example. So Archaeopteryx is an extinct beast having feathers like a bird, but with teeth and a long bony tail like a reptile. Because the known specimens differ greatly in size, some scientists think they are different species rather than individuals from the same species. However, if the specimens belong to the same species in different size because some are younger than others, there should be a positive linear relationship between the lengths of bones between the lengths of a pair of bones from all individuals. So an outlier from this relationship would suggest a different species. Here are the data on the lengths in centimeters of the femur, a leg bone, and the humerus, a bone in the upper arm, for 5 specimens that preserve both bones. So first of all, we're looking at the relationship between the lengths of the pair of the bones. And what are the pair of the bones? They are the femur, and so let me highlight that, and the humerus, okay? Now, which one is the explanatory? Well, here you could argue, oh, well, it could be the humerus indicates the femur, or the femur indicates the humerus, but since we've got one labeled as X and one labeled as Y, we're going to say X is explanatory. Remember the X in the explanatory. And the response is the length of the humerus. So actually, I'm going to go ahead and change that to say length of femur and length of humerus, because that's what we're measuring. Okay, next question asks us to review the scatter plot. Do you think that all 5 specimens come from the same species? So if you were to look at it, let's say I was drawing a line, could I do a pretty good line through all of these points? And I could. So I'm going to say yes. And in fact, the dots fall so close to it, I would say that's a very strong, positive, linear relationship. So we're looking strong, positive, and linear. All right. Then we want to describe the scatter plots. So as we learned in the activity, first of all, we always want context. And I could say it's the relationship between the length of the femur and the length of the humerus. But I might as well say as the length of the femur increases, we expect the length of the humerus to increase, all right? And the direction is positive. So if you look, it's going up and to the right. The strength is strong. There are no outliers, and the form is linear. So then it asks us to estimate the correlation. This is very strong. So I would guess that my guess would be 0.9. So definitely greater than 0.8. I'm going to tell you it's actually close to 0.99. But any estimate, again, we're not trying to have you get the right answer on this. You're just trying to estimate the rough value. Now, suppose that a new fossil is discovered. If the femur is 70 centimeters and the humerus is 40 centimeters, do you think this specimen came from the same species? So coming back here, that would be your new point right here. See that? It does not fall at all on that relationship. So we would say, no, it's not from the same species since it's not within the same linear pattern. So what effect will this new fossil have on the correlation? It's going to decrease it. So it won't be close to 0.9 anymore. It's going to pull it down, because it's going to pull the line away from this. In fact, I would guess that the line would probably go something closer to, like this or something like that. Probably be a little bit higher up, but you get the idea. Okay, so that's the first problem. Let me go ahead and erase these 2 marks so that they don't stay on there. All right, now let's go to the next problem. Often, the percent of an animal species in the wild that breed again is lower following a successful breeding season. This is part of nature's self-regulation, tending to keep population size stable. A study of merlins, which are small falcons in northern Sweden, observed the number of breeding pairs in an isolated area and the percent of males banded for identification who return the next breeding season. So here are the data for the 9 years. And I went ahead and I plotted all the points. For right now, ignore that point. That's for a later question, but I went ahead and actually I could probably move it out of the way. So ignore this for right now. Put it on the side there. All right. So looking at this, first of all, the explanatory variable is the number of breeding pairs, and that explains the percent of males returning. So even if I didn't already have this on the x-axis and the y-axis, hopefully from the problem you understand that the percent returning depends upon the number of breeding pairs of the previous season, all right? So, and actually I forgot to add context, but that's fine. So there's your explanatory. There is your response. The direction is definitely negative, so it looks like it's kind of a line like that, right? Strength, I would say moderate, because you can definitely see a pattern here. You might say, oh, that's weak. I'd say that's actually moderate. And in fact, when I have plugged these points in, it's almost strong. So this is an almost strong relationship. So you're going to have to get used to some of the values being stronger than you think they are, okay? So don't think that things have to line up perfectly, ignoring my marks right now, for them to be correct, okay? So, all right, now going on. So we got moderate. There are no outliers. I mean, could you argue maybe that one, but it's kind of just scattered. So it does look a little curved to me. So this does look like it's almost curving this way, right? So I would say it's kind of linear, but it looks a little curved. And you're allowed to do that. You're allowed to do that. So I would definitely say there's some curvature going on in here. All right. Now, estimating the correlation, I happen to know what the correlation is. It's actually slightly stronger than negative 0.7. So it's slightly stronger than negative 0.7. So it is but it is on the moderate side. Okay, supposing next year there were 34 breeding pairs and 55% of males returned. So that's where this dot came in. So we had 34 and roughly 55. We put it right there. Somewhere around there. So there's your new dot, your new point, right? And in fact, I can type that in. New point right there. So is the relationship stronger or not? I would say that it actually looks more linear now because that's kind of tempering thing, making everything good. And I can promise you actually the correlation did improve. It became more negative. That doesn't mean it became weaker. It just became stronger and more negative. So it does become stronger because the new point falls close to the line that would be going through the points. All right, and then our last piece we have here is matching our correlations. So first of all, the strong one, I always like to start with the strongest. So we got one strong positive and one strong negative. So I'm going to go, okay, strong positive, that's my strongest positive number. Remember, correlation is always between -1 and 1. It cannot be 1.2. Where is my strong negative? There's my strong negative. All right. Now I've got, these are all kind of positive, and I have one more negative here, so that's going to help me figure this one out. This is kind of a moderate negative strength. Okay, so you might want to add that. This is moderate. Okay, and I'm going to add strong to this. All right, pretend I can type strong. And so you can see the signs, all right? And this one is strong. Pretend I can type strong again. And now we get down to these guys. So this one's actually a moderate. So which one of these, the rest of these are positive slopes. So we're kind of doing process of elimination because it's very hard to guess exactly. Now there is an applet you can use to guess correlation if you want to practice. But the good news is it's not something that's going to kill you in this class. You'll be fine if you don't totally memorize. But what should you know? You should know strong, Weak over here for sure. This is looking pretty weak as well. This one is actually moderate. So it's 0.607. You can see it's actually very similar in strength to the one right next to it. They're both moderate. They're both about 0.6, but one is negative and one is positive. The big deal here is to make sure that you keep your signs proper. So this one's the weakest relationship here. So I'll put weak. And then here is also a weak relationship, but not quite as weak as that other one. So again, in your notes, remember you have a very nice guideline. If it's between 0 and 0.5, it's considered weak. If it is between 0.5 and 0.8, it's considered moderate. If it's higher than 0.8, it's considered strong. And then you flip it, mirror image it for the negative. So that is everything on your check for understanding.